The name of my lab is the Ophthalmic Biomaterials Lab. We use different biomaterials, synthetic materials, naturally occurring materials, things that we make in the lab with the end goal of making it easier on patients and clinicians to treat ocular disease. Pitt is, I would argue, the best place to be doing this kind of research. You have this synergistic effect where the clinicians can speak to the researchers freely. We're able to work together and identify problems in the clinic that have potential, in my case, engineering solutions. And I think that makes it a much more powerful way to move things forward along that translational path.
Morgan's a very progressive PI, I will say. She's very focused on what she's trying to deliver. She's very good at bringing talent along in her group. And we've seen that in the number of technologies that have spun out.
So commercialization and translation of the things that we make in the lab is really something that I try to underscore to all of my graduate students and postdocs as our primary goal. And the reason why I show up to work every day is because I want to be able to make a difference in the lives of patients. The biggest example of a material or a product that's come out of my lab that it's on its way towards translation is something that we've been calling solid drop. Eye drop medication is inherently inefficient, and it leads to all of these myriad issues that patients experience where they're constantly getting less than the amount of drug they need to treat the disease. And we really decided that the administration of an eye drop is not so bad, it's the frequency that's the problem, and that's how solid drop came about.
My name is Jorge Jimenez, and I'm a fourth-year PhD candidate in Dr. Morgan Fedorchak's lab. Working for Morgan has been extremely beneficial to my training. I work for the Solid Drop project, specifically for the application of corneal cystinosis, which is a rare disease that we are treating with Solid Drop. Most of the people we work with have an interest in bringing science into a product or into some type of clinical application.
About a year or so ago, we had another project in ocular trauma that we called Triagel, which is a point-of-care material designed to support early healing of ocular trauma. We started out with one idea, and then we realized that the way that we were attempting to enter that pipeline in terms of how a paramedic might use this material was not feasible at all. We had the Chancellor's Innovation Award. That was really our first pilot funding that got us the data that we needed, but it was the participation, not the winning, that taught us how to adapt this project into something that had any chance of any success.
She's been a good partner to the entrepreneurs and residents, taking advantage of their background and know-how. They have worked with the EIRs to figure out what markets, what industries, what customers they can go talk to.
I like to say that I have gotten Innovation Institute bingo, because if there is a program or some type of workshop or seminar or whatever it may be, competitions, I think I've done enough to get at least 5 in a row. We were through the Coulter program, we did blast furnace, first gear, second gear, and really any opportunity that we've had to learn to speak that language of commercialization.
I think Morgan's a natural leader. She very much is a role model for those that want to be entrepreneurs, especially within a university environment. I don't know that she necessarily wants to be an entrepreneur outside of the university, but she has unique talents to make the work within the university get out to market and really have impact.